Thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So, today we're looking at finding the volumes on base where the shapes are squares or rectangles. So in number 1 it says find the volume of a region whose base is x squared plus y squared equals 1. Now that is a circle centered on the origin with a radius of 1. So 1, 1, negative 1, negative 1. Now for part A, the cross-sections are squares, and for B, the cross-sections are rectangles whose height is twice as long as the base. So the way we have to picture this is if you think about this is our base. This is the bottom of the square, and then it sits up above the region like that. Now, a circle is not a function per se. It's actually broken up into two functions. It's written as one equation, but the top half would be written like this, 1 minus x squared, and the bottom would be written as negative square root of 1 minus x squared. Now basically what we're going to do is we're just going to write the integral and call it good. Because if you're preparing for the AP test, most of the AP tests either have you set up the integral and then calculate it on a calculator, or just set up the integral and that's it. And that's all we're going to focus on. And so what we have to do is we have to figure out, okay, this is a square slice. And so what we have to do is we have to figure out, all right, how thick is it? Now notice that the slices are perpendicular to the x-axis, and when that happens, that means the thickness is dx. Now the length is from here to here. And usually when we measure length, it's from this point, the top, minus that point on the bottom. So that's square root of 1 minus x squared minus negative square root of 1 minus x squared. So that is 2 square root of 1 minus x squared. And so the volume of this slice of the square is 2 square root of 1 minus x squared. That's the base. The height is the same thing. 2 square root of 1 minus x squared times dx. So that means we have 4 times 1 minus x squared dx. And so that is the volume of the slice. And so now we need the total volume. And so to get the volume of the total shape, this is where we take the integral. And so we have 4 times 1 minus x squared dx. And we're adding up all the slices from here to here. And so that is from negative 1 to 1. And so there is our integral. Now for letter B, the work is very, very similar, except now the height is twice as long as the base. So if I have this picture, now here is the base, but the height is twice as long. But we already said, what is this? This is 2 square root of 1 minus x squared. The thickness is dx, and the height from here to here is going to be twice as long. So that's 4 square root of 1 minus x squared. So the volume of this slice is 2 square root of 1 minus x squared, 4 square root of 1 minus x squared dx. And so when I put these radicals together, we get 8 times 1 minus x squared dx. So now if I want the total volume, I take this slice, and some people will put the coefficient out front. You don't have to, but you can. Especially if you're taking the AP test, they will put any coefficients out front. So you don't need to worry, don't let that freak you out. And so we're adding up all the slices from negative 1 to 1. So there is our integral for letter B. For number 2, find the volume of a region that its base is between y equals x squared and y equals 2 minus x squared, whose cross-sections are perpendicular to the x-axis. So here we have the graph of x squared, and here we have the graph of 2 minus x squared. And these two meet at -1 and at 1. So our slice is right here, and it's a square. Now our thickness again is dx. Now the length is this top curve, which is 2 minus x squared, minus the bottom curve, which is x squared. So we have 2 minus 2x squared. So that is the base, the length of the base, but that's also the height. So the volume of this slice of this region is going to be 2 minus 2x squared quantity squared dx. And so since that's the volume of the slice, then what we do is we say, all right, we're adding up all these slices from -1 to 1. And we put 2 minus 2x squared dx in there. For letter B, now we have rectangles whose height is 10 times as long as the base. So you have -1 and 1. So our thickness again is dx. Our base is 2 minus 2x squared, and the height is 10 times as long. So it's 20 minus 20x squared. So if I want the volume of the slice, one thing I might do is I might take the 10 and factor it out, so that I can write it like this: 2 minus 2x squared dx. So now I want to add up all these slices from -1 to 1. And I'll put the 10 out front. So that's quantity 2 minus 2x squared dx. For number 3, here we want to find the volume of a region whose base is between the x-axis and 2 square root of sine x. Now sine is 0 at 0, but also at pi. So each of these slices is a square. The thickness is dx. And so the top is 2 square root of sine x. The bottom is 0. So it's just 2 square root of sine x. And so that is also the height, 2 square root of sine x. So the volume of the slice is length times width times the thickness. So that's 4 times sine of x dx. Because the square root of sine x's, they cancel out the square root, and the 2 times 2 becomes 4. So now we're adding up all these slices from 0 to pi. And I'm going to take that 4 and put it out front. 4 sine of x dx. Letter B, same region, but now the rectangles is 1/10 as long as the base. So here's my slice, and the rectangle doesn't stick out very much. So we have 2 square root of sine x. Now the height is 0.2 square root of sine x, and the thickness is dx. So the volume of the slice equals 0.4 sine of x dx. And so we're adding up all these slices again from 0 to pi. So we have 0.4 times the integral of 0 to pi of sine of x dx. And the last one, number 4, find the volume of a region whose base is between y equals 2x cubed, y equals 0, and x equals 2, whose cross-sections are perpendicular to the y-axis. You have to be aware of that, because that changes things. So here's x equals 2. This is y equals 2x cubed. And so this is going up to 16. The slices are right here, because we have this right here, 2x cubed, we have y equals 0, and we have x equals 2. This is our region. And so this is our slice. So in this problem, the slices, because they're this way, have dy as their thickness. Now, the length. Everything has to be now in terms of y. And so the way this works is, what we're going to do is we're going to solve for x. So I'm going to take this equation and get x by itself. So first, I'm going to divide by 2, and then I'm going to take the cube root. So x equals cube root of y over 2. So once it's all in terms of, once it's got x by itself, now we can figure this out. And so which of these is further away from 0? It's this one. So this is the quote-unquote bigger one. So it's 2 minus cube root of y over 2. That's that length. And so the volume of the slice is 2 minus the cube root of y over 2 squared, because the length and the height are the same, times dy. And then when we write our integral, we're adding up all these slices according to y, from 0 up to 16. So it's 2 minus the cube root of y over 2 squared dy. There is our integral. Now for the last one, same region, only this time we have a rectangle. So this thickness is dy. This is 2 minus the cube root of y over 2. Now the height of the rectangle is 4 minus 2 times the cube root of y over 2. It's twice as big. But I think most people prefer just to write it in factored form, like this. So that when we write the volume of the slice, we get 2 times 2 minus the cube root of y over 2 squared dy. And so our integral puts the 2 out front, 0 to 16, of 2 minus the cube root of y over 2 squared dy. And so there's our integral. Thanks for watching. If you liked the video, hit that like button. And if you want to see more, click the subscribe button. To support the channel, click the Patreon link. All the descriptions to help support the channel below. Thanks for watching. And remember, the best way to understand something is to do it.